Alright, so we're moving on to predicate logic today, Chapter 8, and this is the last of the forms of logic that we're going to look at in this course. It is the most recent addition to traditional logic, going back to the very late 19th and early 20th century. Now, predicate logic is intended to combine together the previous two, because as we saw, there were things that you could do with Aristotelian logic that you could not do with propositional. And there were things you could do with propositional that you couldn't do with Aristotelian. So predicate logic wants to be that unifying theory that brings all of this together. Now, predicate logic is going to look very similar, and you're going to use a lot of the same symbols and things that we've been dealing with before. In terms of the basic ideas, you're still going to have sentence letters. You're still going to have your basic symbols for conjunction and disjunction and negation, conditional, biconditional. Everything is going to work the same way. You're still basically going to be able to use modus ponens, modus tollens, all those different rules that we talked about. So that a lot of the stuff that you learned in the last chapter is going to be applicable here as well. So there's not a whole lot that's new to this. But what is going to look a little bit different is going to be the basic setup, because instead of a single letter, there's going to be two letters now that are involved. So let's take a simple statement here, such as Socrates is mortal. Now, under propositional logic, you were taught that we just assign a sentence letter to that, usually the first letter of your subject, so I would just call it S for Socrates is mortal. But under predicate logic, we're going to use two letters here. One represents the subject, the other represents the predicate. And so the predicate is always going to come first in predicate logic. So mortal, I'm going to use a capital M to represent mortal. And then the Socrates is the subject. I'm going to use a lowercase s to represent that. And so in predicate logic, in terms of translating a basic statement, the capital letter the capital letter is always the predicate, and the lowercase letter is always the subject. Okay? So that will always be the case with regards to your basic form of predicate logic. The capital letter is the predicate, your lowercase is the subject. So you need two different letters for each statement that you're making. Once you get accustomed to that, and of course keep in mind that these are still arbitrary, even though we tend to use the first letter. So if this were Socrates is silly, you couldn't use S for both of those. You'd have to use a different letter or a different symbol of some sort, to put in there. But in any event, the capital letter is the predicate, the lowercase is the subject. If you want to do basic statements like we've been working with, I want to say Socrates is not mortal. Well, then very simple, you put the tilde in front of the ms, right, to say that Socrates is not mortal. If you want to do a conjunction, let's say we've got Socrates is mortal, but now let's say Socrates and Aristotle are mortal. Socrates and Aristotle are mortal. Well, basically you've got two statements there. You've got Socrates is mortal, which you've already seen, M-S, and we've got Aristotle is mortal, which would be M-A, and it's a conjunction, and, so you just put the dot in there. Or, if you prefer the symbols that I'm using for the exams, MS, ampersand, MA, you can use either one. If it's more comfortable for you to use that, you can use it if you're typing or whatever. But anyway, that's the basic idea. If I wanted to say either Socrates or so either Socrates or Aristotle is mortal, then instead of the dot it would be the wedge, right? MS or MA. If I wanted to do a conditional, you'd have the horseshoe. If I wanted to do a biconditional, you'd have the triple bar. Okay, so it works basically the same, except you're dealing with two letters instead of the one, so just keep that in mind. Now this is in terms of anything that we would deal with in the propositional line of logic. It works the same in terms of predicate logic, except for the fact that you've got the predicate subject model rather than the single letter. Okay. But what about those categorical statements? Remember back in chapters 4 and 5 we had the categorical statements. All A are B. No A are B. Some A are B. Some A are not B. And we learned that these are a universal affirmative, universal negative, particular affirmative, and particular negative statements. Well, we can use predicate logic, that's part of the magic of it, is that we can use predicate logic, but it's going to be set up a little bit differently, and we're going to need two new symbols to become familiar with. First, we have the symbol of an X. And the X we would use in both of these because they are universal claims. And so if we're using universal claims, we're going to put that X in there like that. The particular claims, these are called existential statements, and so the symbol you would use here would be a backwards E with an X. I haven't made up the exam that includes this yet, but I doubt that there is a backwards E on there, so I'll probably turn it the other way around. But it's supposed to be a backwards E with the X. And so this symbol implies universal, this symbol implies particular or existential. All right, now we think about what's being said. All A's are B's. Every A that exists is a B. So, if AX, then BX. What this says is that for every X, if that X is an A, then that X is a B. Every A is a B. Okay? All cats are feline. For every X, if that X is a cat, then that X is feline. With the negation, no A or B, again we use the universal quantifier of X. AX, then tilde BX. For every X, if that X is an A, then that X is not a B. Okay? No cats are dogs. For every X, if that X is a cat, then that X is not a dog. Okay? So every time you want to translate all A or B, this is what it's going to look like. Every time you want to translate no A or B, that's what it's going to look like. Now obviously if we're using actual words in there, like all cats are feline, it would probably, we'd probably choose to go for every X, CX, then FX, you know, so we might change in that respect, but basically the formula is exactly the same. When we're dealing with the existentials now, some A are B, there exists at least one A that is also a B, so here we would have the backwards E with the X, the existential quantifier, then AX and BX. So for this particular X, if that X is both an A and a B, Right? Some cats are gray. So for this particular x, this x is both a cat and gray. Okay? And some A or not B, again the backwards E with the x, the existential quantifier, AX and tilde BX. Okay? So again, for this particular x, this x is both an A, this x is an A, but it is not a B. So some cats are not gray. Right? There exists at least one, and that's why it becomes useful, like I told you way back when, to translate these as there exists at least one that is, or there exists at least one that is not. So there is at least one cat that is not gray. For this particular x, that x is a cat, but that x is not gray. All right. So anytime that you're translating from the categorical logic into our new predicate logic, this is the symbolism that you would have to use in terms of those. Now, as you look through 8.1 in your book, you'll find a lot of different examples given to you there that demonstrate all of this stuff. And so you can see, for example, right around page 457, it's talking about these ideas with specific examples. So, for example, here, all skyscrapers are tall. For every x, sx, then tx, right? But it's, again, even though I've given you the generic A and B, you could translate whatever letters you needed into it. On around page 459, there's another list of examples there just to kind of help you out. Just to look at a couple of them. There are happy marriages. Well, we have to think about what exactly is being said there. Right? Remember back to, it might be useful to go back and look at section 4.7 again on translating from ordinary language into categorical language. But a lot of this, like I said, it's common sense. You look at the statement, there are happy marriages. Does that mean that every single marriage is happy? No. It means some of them are. So basically, there are happy marriages means that there are some marriages that are happy. Hence, we see them writing it symbolically, translating it as the backwards E with the X, the existential statement, mx dot hx. Every pediatrician loses sleep. Well, I mean, every implies all of them, right? So all pediatricians are people who lose sleep. So they've translated it with the X, the universal quantifier, px, then lx, and so on. So that that chart could help you a little bit there as well. All right. So let's go ahead and take a look at the bottom of right around page 461, 8.1, the exercise here. And they've given us some statements, and it's simply a matter of translating these statements from the way that we have them written here into this symbolic form for predicate logic. So the first one, very easy. Says Elaine is a chemist, and they even tell you what to use for the predicate letter, in this case C. Elaine is a chemist, so C for chemist, lowercase e for Elaine. Right? And of course they start out very simple like that. And then they start to build a little bit. So let's take a look at number 3. Well, yeah, let's look at 5. 3 is kind of easy. 4 or 5 will give me a chance to remind you of something. Intel designs a faster chip only if Micron does. And they want you to use D for designs a faster chip. So basically we have Intel designs a faster chip only if Micron designs a faster chip. Now remember, only if is a conditional. And remember also that what follows if is the antecedent, but what follows only if is the consequent. So basically what we'd have here would be DI horseshoe DM. Right. So Intel designs a faster chip, then Micron designs a faster chip. Okay. And then, of course, they'll give you some with the conditional statements as well. With the categorical statements as well. So take a look, for example, at number 9. No novels are biographies, and they want you to use N and B. So no novels are biographies. That's a universal statement. So you'd have the X, the universal quantifier, and then the NX, horseshoe, BX, like that. So for every X, if that X is a novel, then, it's a negative statement, wasn't it? So tilde BX. There you go. So for every X, if that X is a novel, then that X is not a biography. Okay? And basically that's the way that it's going to work. So I'm going to let you try 2 through 20 for 8.1 even. Okay, I did a few of the odds for you, so you can do 2 through 20 even for homework. And as always, if you have any questions, feel free to write in, email, or the discussion board, and I'll be happy to get back to you and answer those. All right?